Hello, everybody. I'm Kipp Snow, Director of the Transportation Distribution and Logistics Institute at the Community College of Baltimore County.
Hey, everyone. I'm Mike Singer, the Community Manager for Baltimore and Chesapeake Bay Shipwatchers, the sponsor for Two Guys Talking Ship podcast. And we have a special edition for you, episode 65 today.
Special edition. We have guest speaker today. So this is Jim Harkness, who will be joining us. So we had Jim back on episode 53 back in July of last year, and so they want to come back and provide an update and answer some questions. We've heard some questions from some of the viewers, and so we've collected some questions that we're going to ask him. I appreciate his time that he's going to spend with us on this. So make a point to listen to the interview in its full, because there's a lot of information that he's able to provide about the bridge. So
a lot of detailed information. Hey, so if you're new to the channel, give us a like, subscribe, or hit the bell to be alerted to new podcasts as they come available.
All right, so why don't we, this is a pretty lengthy interview. Why don't we go on into the interview here? So,
let's do it.
Here we go. All right, hello everybody. We're back here with a special guest in this episode. It's Jim Harkness. He is the MDTA Chief Engineer for the Key Bridge construction project. Welcome, Jim. Glad to have you.
Thanks, guys. Welcome to you.
Yeah.
Well, I'm glad to be back.
Yeah. Absolutely. So you joined us back over the summer, about episode 53. So all the viewers, if you want to go back there and listen to that episode and hear what Jim had to say, go ahead and go back there. But it's been about 6 to 7 months since we last had you on, and there's been a significant amount of work and movement that's taken place with the bridge project. Could you give us an update as to what's transpired since we last had you on?
Yeah, I'd love to. We've made a significant progress, had a lot of activity since we last were chatting. So we were performing some of the what we were calling pre-construction activities at that time. We had a boring program, so geotechnical explorations, where we were doing soil sampling. We had split that out into 2 phases, so we were kind of getting through phase 1 and into phase 2 at that time. We've kind of completed that work. We were doing some other field work for sort of getting some inspections of properties in the area, kind of pre-construction inspections. We were getting those wrapped up. Those were all done. We installed noise and vibration monitors around the project site just to keep tabs on our impact to the areas around the project. And then we were excitedly getting underway with demolition at that time, and so we've really progressed well on the demolition of the existing structure. So our subcontractor has basically completed the demolition work. So they're just sort of moving out the last of the materials and kind of some of the ones on the south side, the concrete that was rubbleized. We're actually using that on site, so they're taking that from where they rubbleized it and pushing it down onto the peninsula or the causeway, and then kind of making crane mats and being able to build an access road there using that material. On the north side, everything's gone. It's kind of graded down. So
wow, the abutments are just totally gone.
Both abutments are totally gone.
Wow.
Kind of graded out. Remnants of the roadway are still there. That wasn't part of the scope for this demo contractor. So you'll see, if you were to drive on the loop road on the north side, you would still see the road bed there. But that's to come out later in phase 2. We needed to get the bridge structure out of the way. So we took care of the structure that's on land, and then of course there were still parts of the existing bridge that were in the water, so the marine spans of the old bridge. Now those still remain, and they remain because it was sort of this effort to really take care of the stuff that was going to be in the way of the new bridge. So the existing bridge, we've finalized the alignment of the new bridge off of the old alignment. However, when we get back on the land, because we're staying within our right of way, we need to tie back in to the existing highway at some point. And so the portions of the bridge over land were in the way of that. So it was critical to get those out of the way first. And we could defer the work on the marine portion until it made more sense. And it made sense in that those are pretty tall, high piers. So it's going to take
like 900 feet, aren't they? Between those four piers.
They're not. Those are not quite 900 feet, but it's a 400 foot, I think, span there. And so they're significant. It takes a lot. So it takes big equipment to get those down. And the contractor will have significant equipment here when they're building the bridge, and so it just kind of makes sense to let the contractor decide, now's a good time. I have a little bit of downtime with this equipment. I can go get those beams down. I can get those concrete piers taken down. So that's why we kind of deferred that work. So the portions of the former bridge that are in the water will be there for some foreseeable future.
It is pretty wild to see them, to see them just kind of sticking up there, with everything else gone. It is kind of surreal to see that.
Yeah, it stands out, and that it's disconnected from the land now is kind of makes it really an unusual sight. But again, it was just one of those things that we were taking care of the things we needed to advance the project as quickly as we could, and it was that critical stuff that was on land that we needed to get out of our way. So some additional work we've been doing is the test pile program. So we, had fabricated 12 of our piles. We had, brought those to the site in October, started driving those into place. So basically, we've split the test into two separate locations. So we're testing at the main piers, the pylons. So that's where we're conducting our load tests. And so we drove six of those tests at each of the two locations. And so we now have those completely installed, and we've actually carried out the load tests at pylon 24, which is on the south side, so the south main tower there. And then we'll be following up in probably February with the second test at the north side. And so the contractor was able to run through the test. So we test in two directions. We test laterally and axially. So, we pushed on one of the test piles and the other sideways on one of them, and we pushed down on the other one, so that we were able to test in both directions. Obviously, when you're testing vertically, that's for bearing all the weight of the bridge, everything associated with the traffic and the wind loads and all the various loads that go along with that. And then the lateral, to resist some of those lateral forces, and also we're testing for our vessel protection system. So, it has two requirements there.
So if I could jump in. So when you were talking about, the vertical and the horizontal, for lack of a better term, I know I'm not using the same language. I was thinking, so you've got all this weight of the bridge coming down for vertical, but then for horizontal or lateral, it'd be a lot less. And I wasn't thinking about the ship protection. And so are they both kind of tested to the same amount, or were there differences, and who was greater?
Right. So I think you kind of generally had it right in that the lateral test has lower requirements for the strength there. So the amount of weight just from the materials that make up the bridge alone is a very significant number. Then you you tack on whether it's the live load from traffic going over it or dead loads from
Dynamics, frequency, right? I mean,
the winds, the movement of the bridge. So those loads are dynamic and they're transferred to the foundations, and so we need to be able to resist that. And so that's why that's a much greater number. So we actually ended up testing that in the lateral direction. I'm sorry, in the axial direction. So vertically, we tested out to 11 million pounds. So on that test pile, we tested up to 11 million pounds, which was more than we initially thought we were going to need to test to. But because the test was going well, we decided to test it a little higher to just give us a margin of safety if something,
right,
because we're not fully designed. And we wanted to just, in case something developed during design where we needed to have that
right,
higher capacity, we already knew we had it.
Right. So you're going along and you have a little bit of a problem, or you see like a little bit of a higher load or something that you're not expecting, and of course you already have a margin, right? You already have a margin designed in, I would imagine.
Yep.
And so, things were going well. So just pardon the unknowing nomenclature here. So did you just so what they called it, like the birthday cake that was sitting on top of the pile? Yeah. So did you just, crank up the actuators a little more to produce more load, or how?
Yeah. So the way that's functioning, like that birthday cake is the final piece of we have this H-shaped load frame that we called it. And so that was really resting on four corners. So these four piles that we had installed. And so, we're trying to put this axial load pushing down. And so obviously it has a equal force that tries to push back up. So those four corners essentially held the frame in place. And so those four piles are actually splitting the load, and then sharing that from uplift. So, they're kind of doing the opposite of what they would normally do, which is, resist against the, sort of the load coming down. They were actually kind of holding it so that we could actually push the test pile down. And then that birthday cake is a, a set of 9 very large jacks, and those 9 jacks work together to just, kind of incrementally up the pressures. So obviously that whole test pile is instrumented. We know the pressures in those jacks. We know what we're kind of doing, and we're measuring, deflections and stresses within the pile material. So we understand sort of if we're getting towards any limits, if we're seeing anything that's concerning, and then. So once you start kind of loading that, and it's sort of the static loading that you're doing, and things are going well, you can bump it up. So we got to the level where we had thought we needed to test to, and things had gone really well. So we took that extra step, and we're able to get a little more headroom in case we need it as we finalize design.
That's awesome. That's really cool to hear. And so kudos to MDTA and Keybridge Rebuild pages and social media, because you guys have been sharing some incredible stuff. Now, we have our live stream camera, but that thing is, 3.5 miles that way. So we're trying to see what's going on, but nothing compares to, your drone pictures and the close-ups, showing the test frame and the birthday cake, and all the gantryways and the walkways and catwalks, and how they cut windows in the piles, and you could never have seen any of that if it wasn't for the organization sharing all that. So kudos to that. I didn't expect to really see even half of what you shared. So,
yeah,
so the transparency, not that there's anything to hide, but So the transparency of showing people what all goes into it,
Yeah.
how complicated, how many different structures are involved. Okay, well, we put 6 piles in the water. Well, what's taking so long? Oh, geez, well, we've got these 10 or 15 other things to do. We've got to cut. We've got to put catwalks in. There's all this. So thanks so much, because you guys painted an incredible picture, and if it wasn't for you sharing it, we wouldn't know. So
Yeah.
really cool stuff.
Yeah, it's great to hear. I mean, that was, very intentional, trying to, really help people to understand it's a significant project, just from the, the importance to the region and the state, and obviously, just having this project is important, but I think, it's also an opportunity to kind of really highlight all the detailed work that goes into, a project of this scale. And Brad, and, other, public engagement teams have been doing an excellent job just with this, sort of this, putting this information together. I think, the materials they're creating are innovative, and it's I think connecting well. It seems like it's landing with a lot of folks, and so that was a very intentional effort, and we were proud of. We think it's going really well, and just the variety of ways that we're getting information out to folks about what it takes to build a bridge like this, and I think we've certainly found the value in the Shipwatcher cameras, and kind of being able to focus on what was going on the water, what was going on the land, and you could just from day to day you could see that hey, there's a whole girder line missing, so there's a whole span that and here's the progress, and so that was very useful too. But yeah, getting up close and sort of explaining some of those things, like what is all the bubbles that you see in the water, and what makes that, and what is the purpose, and just among the variety of all the things that you need to do on a super large and important transportation infrastructure project.
Yeah, and I mean, obviously there's the accident that happened, which is horrible, but as we're building this bridge, we're educating people about, oh my gosh, what all goes into taking this thing apart piece by piece, and how do you do that? And then what all goes into the testing, and what testing is required. So just some really, really interesting stuff. I'd like to get into maybe a few questions if we could. And I had sent some, but this one right off the top of my head, since we're talking about demo, and we had talked before about how some of the pieces of the old bridge would be left. So let's take that A pillar that's out there, for example. Will that be just kind of cut down? Are they going to take the top of the A off and just leave the square out there? Is that kind of the plan?
Yeah, good question. Right. So in addition to the pieces that are, the remnant pieces of the former bridge that we were talking about earlier, that would be demoed, we will be demoing some of the piers that were, part of the collapse actually too. So, that the former one of the main piers, that would be kind of taken down, but not completely removed. So we'll be taking the majority of what's above the water down. But if you think about the other main pier, the one that was struck, we'll be kind of cleaning that up. So right now it's a little rough with some exposed rebar and concrete, but the contractor will be responsible for cleaning that up, and then that would remain. And so both of those would kind of look the same when we're all said and done here. Those would remain. It's a something we coordinated with the Coast Guard, with Army Corps, in terms of being allowed to keep that, rather than have to do a lot of work below water trying to remove what is very substantial foundations for those two main bridge piers, and so through that coordination, we're minimizing the impacts on the environment and just also,
And it
a benefit.
sort of acts as a free dolphin.
It is essentially, kind of going to be incorporated as part of the, new bridges vessel protection. Yeah.
Interesting. Outside of those 4 marine piers that come off of land, right, the ones we were talking about that are still there, is there other underwater work that needs to be done? Where you go down to the bottom, whatever, 6 inches off the mud, you take the giant diamond saw thing, and will there be some of that in addition to those 8?
It would just be, the other piers that collapsed initially. So we have to go, down to mud line on those, as well as like you said, there should be a total of 6 piers in the water that are still standing. We got to take those down after the steel's gone. Take those down to water, then do subaqueous work in order to remove those to the mud line. So the permitted parts to remain, whereas we said the 2 main piers, those are allowed to remain, and then the existing dolphins would also be allowed to remain.
Gotcha. Very interesting. So, this is always something that folks always ask, and everybody's curious. So, do we know, will the bridge name be the same? Will it be changed?
I'm not sure. So at this point, we're still working under the project name of the Francis Scott Key Bridge Rebuild Project, and then I'm not sure what legislatively would happen in the future for any change to the name.
Okay. Now, Kipp and I did cover. There was a bill introduced in the House, right?
There was
change it, but I don't know if we followed up or kept track of that.
And a lot of times those bills, they don't make it through House or Senate or even out of the committees for for any number of reasons. So it could be that we've got to wait for the right
never
bill
went
to
anywhere.
be introduced. Yeah.
Well, maybe
It
you and I
didn't
could
make
look-
it. Yeah, it didn't make it out of committee last year. If I'm
interesting.
correct.
Thank you. Okay. So I don't know if this is in your purview, but do you know if there's going to be any kind of memorial to the folks that were lost in the accident?
We definitely have plans for a memorial. I think that effort is sort of underway a little bit and just still needs to be developed. But there are certainly plans to have some memorial, but a site and exactly what that looks like and how it would be delivered has yet to be determined.
Okay. And then, do you remember that key trestle remnant that was sitting on the causeway on the north side? It was kind of laying on the 45 degree. It was kind of laying there forever, and now it's gone. It's been gone for months. Is there plans for that?
I think, yeah. So we had some parts of the former bridge that were there stored on the causeway, and then we have some of that still in storage for a possible memorial. Again, we don't know what a future memorial looks like, so we kept some pieces in order, in anticipation of its possible use as a memorial. So we do have some of that, not all of it, but some pieces. And obviously, we still have some steel that is on the remnant portions of the bridge. So there is additional steel material if we get to the point where we kind of have a plan for a memorial. There's some materials that could be used there too.
So the Key Bridge Indiana Jones warehouse is what I'm picturing it.
I don't. I don't think it. I don't think we have anything quite to that extent.
Yeah, that was a really big room at the end of that movie.
Right.
So, and here's something that so we like to call it on the chat room in the camera, the Holiday Inn Express engineers, right? So everybody comes in and talks about, no, this should be this way and this, and there's some very knowledgeable folks in there. There's a guy who worked on the Tappan Zee Bridge in New York, and but so people are assuming. So we see some piles that come in that look like they're painted or coated. And we
Okay.
see some that are kind of allowed to rust, for lack of a better term. And most people were assuming that, if it was to be not a test pile, something they're actually going to use for the bridge, that it would need to be coated. Can you explain the differences or how that works?
Yeah. So I think initially on those of the 12 that we had for the test pile program, we had 4 that were uncoated, and then the 8 were coated. The 4 that were uncoated were the test piles. So the test piles were uncoated because after you test on them, you cut them and remove them. So they didn't need to be coated. The coated piles were possibly permanent pile for the pylon foundations. So what you will see now that we're driving some production pile, which I didn't really hit on, but since our test pile was successful at the Pier 24 location, so the South Pier, where we've concluded the test pile load testing, we're driving production pile there. So those piles are uncoated piles. That's because they're part of the vessel protection system. So the vessel protection system, the design of that pile, didn't require the coating in order to reach the 100-year life. But on the footings, so the same thickness, but obviously carrying different loads. But the footing pile did, we put a coating on it. We specified a coating just as sort of a belts and suspenders, just to be certain that, there's not a corrosion issue, and that we get that 100-year lifespan out of those piles. So that'll be the difference. So if it's an uncoated pile going in, it's part of the vessel protection system.
Very interesting. Very interesting. So we're starting to do temp trestle piles, right? We're starting to drive those.
That's right. We started last week.
So when the permanent piles are the big 8-foot by 220-foot piles come in, they're coming in from out of state on a barge. You can't miss them. But the temp trestle piles, there's got to be hundreds of those, but they're a lot smaller.
Yeah,
so
that's right.
Where are they made? Where are they stored? Because I don't think we really see them as much before they put them out there.
So as you said, the very significant, pile for the vessel protection system and for the footing, bridge footings, those are being fabricated in Texas, and so it takes it takes a significant facility to deal with, piles that are, up to, more than 250 ton, right, when they're all said and done. So, that's where our contractor is currently, found the fabricators and able to get those pile made. And so those are coming up in the Gulf area. Now, as you said, it's smaller for the trestle pile, so it's still a steel pipe. So it's still a steel pipe pile, except now it's a 36-inch pile for the trestle. So there's a significant number of those that need to be driven. And I think, all told on the trestle system, we're going to be almost 3.5 acres of area that we're making out there for trestle, to support the work. And so it is a significant number of pile that we'll be driving just for that. And so that 3-foot pile, obviously you can truck that, the pieces of that around. So the contractor actually has a laydown yard over at Trade Point Atlantic. It's the same area that we used for processing the materials from the former bridge during the emergency. So Kiewit was able to have a lease with Trade Point Atlantic over there for that same area, and a little bit more. Actually, they needed more area, and so we have teams working over there, taking the pieces that come in by truck, and then creating them and welding them to length, getting them to the length we need, and then bringing it across to the project site.
Oh,
So
they're
there's
actually doing some
work.
manufacturing, for lack of a better term. They're not coming in.
Yeah, fabrication. Yeah, they're fabricating
fabricating.
right there. Yep.
Wow.
Interesting. So,
Yeah.
as you go from 35 feet to 5 feet as the bridge gets closer to the shoreline. Are the piles going to be, do they get gradually shorter as you go, or do you just cut? How does that work?
Yeah, they do get shorter as you go. So the sort of went through that geotechnical exploration that we did, those 2 phases of work, getting those borings, it sort of maps out for you, the depth of what we call the Patapsco layer. So the hard layer that we're driving into in order to provide us with all that support for the bridge. And that the depth of that layer actually kind of comes closer to the surface as you get closer to land. So the piles, as you approach land, are no longer, over 200 feet. They start to decrease in length somewhat significantly. And so, but that's not the only change in the dimensions of the pile. So as we get off of the cable-stayed bridge foundations, so there's 6 piers that make up this, the cable-stayed bridge portion of the bridge project.
Right.
And then we get into more of the traditional piers. Those piers, we start to go down in size. So we drop from the 8-foot down to a 4-foot pile.
Oh,
And then
okay.
that's when we're still in the water. So when we're in the marine footings, we're going to have a 4-foot. And then when we get to land, we're able to reduce it again. And we're the same size as the trestle. We're to a 36-inch pile when we're on the land for the foundations for those bridge piers. So we're, you kind of take into account the depth that you need, and of course you start to have less load that you're carrying too, because you're kind of coming down and you don't have that same height that you do any longer. So you're reducing, the loads that you need to carry. So then you can, shrink up your foundation and your pile size and start to, right size the materials for what you need to support.
Interesting. So when we talk about those football field size protection around the main piers or around each of the 6, right? So there's going to be 6 of those?
There's six piers that we needed to protect in accordance with the specifications from AASHTO. And so they're not all the same size because, some of the factors that go into the design of these of the protection based on the specification, you start to get lower energies the further you get away from the channel. So then that's kind of again, you just sort of right size your protection based on the the amount of energy that you have to design against. So they're not the two, you had it right that it's a more than a football field size on the 2 main piers, the pylons, and then because we're even further away for those tie down piers and transition piers, they're smaller but still very significant.
And then I attended an event where MDTA was there, Pasadena Sport Fishing, and you guys went over some stuff. So I remember some of that. Did you say like the football size protection islands on the main piers, their concrete is 20 feet thick? Is that what you said?
Yes. So they are 20-foot thick, and the footings for the bridge are, the same dimension. So the concrete that'll go on top of the pile for the footings, that's a 20-foot thick cap. And then the vessel protection systems have the same dimension there, 20 foot.
Wow.
So it's a large mass. Designing it again for the ASTO to meet the ASTO specification. It kind of tells you the amount of energy you need to dissipate, and then so you're able to kind of calculate how much mass you need to kind of slow that energy. So. Mm-hmm. It's all that calculations that kind of go back and forth. Once the ASHTO specification sort of sets up what you're designing for, then you kind of work into the numbers exactly what the dimensions need to be in order to to meet that specification.
Sure.
The spacing on those pylons is now set so that this bridge project ended up being the largest cable-stayed bridge in the United States. That specification kind of determines how you need to protect those piers, how many piers. So, it ended up because of the vessel information that we have and the type of soils that we have, you end up having to protect six piers on this bridge. So it's a significant number of piers to protect relative to other bridge projects that around the nation.
I could mention the height of the bridge and the ships. Is there any work that's being done with the Bay Bridge team, or are you on the Bay Bridge team? Like, I don't know where, we've got two major bridge initiatives that are happening at the same time, and they both kind of have the height restriction, component to this.
Yeah, I mean, the good thing is, both of those projects are MDTA projects, and so I do participate. The planning effort for the Bay Crossing study, NEPA Tier 2, is under my purview as well. So we're able to work on that project, and we did this very similar, as you can imagine, vessel impact report for the Bay Bridge, and so the Coast Guard reviewed that as well, and came to the same determination of a future bridge would have to have the same clearance of 230 feet under the over the channel, and so there is consistency there. Obviously, the Bay Bridge project is moving forward. We're getting to the point where our board was able to vote on a recommended preferred alternative. So we still have all the alternatives on the table. Our board just was able to approve a recommended preferred alternative, and then we're actually getting ready for public hearings on all the alternatives that are in the report. So we're going to be we have that draft environmental impact study out. So it'll be available for public comment, and then in early February, we're going to have 2 in-person meetings and a virtual meeting for that project.
Very interesting. Now, just so people aren't confused, right? I mean, the Bay Bridge thing has been going on for like 9 years, exploring those 14 different locations. So when you're talking about alternatives, you're talking about alternatives at location 7, the current location at the Bay Bridge, and the specifics of how you would build or take those down, right? So that's what, when you say alternates, you're talking about, the same area, just how to do it.
So so we broke it into 2 tiers. So tier 1 was that, all those alternatives up and down the bay, all those different locations, right? So we were really just trying to go through tier 1, which was siting the project, and we ended up on, the location, the existing location. So in tier 2, now we determine, okay, we have the location. What is the new project? And so that's what the alternatives are. So they present a variety, and we did this last year. We were out publicly, with meetings in terms of what's the lane configuration. How many lanes on land, how many on the structure. Where are the structures located relative to the existing structures? And so that's what we're going to the public with. That's what we want the feedback on. The recommended preferred alternative. We want input on that, but we also want input on the other alternatives as well. We need input on all of them. So, that the variety of alternatives in terms of how many lanes and where the bridges would be located relative to the existing, that's all still open for comment. And that's what we'll be going through.
Because I think how you worded it, when you all voted on the preferred one, you kind of run with that in your head, and you're like, oh, so it's decided. Well, no. Okay. I didn't realize that. So I'm glad thanks, Kipp, for leading us down the Bay Bridge conversation. So
yeah, and I appreciate the opportunity to kind of flush that out a little bit, because we did notice some of that in some of the coverage, that it was like a sort of the board voted. They did, but they weren't. We were just kind of making it known what, as the owner, we believed, was the basically telling folks this is where what the owner is looking at as the preferred alternative, but that doesn't decide anything. It's still a hearing process. We're still soliciting all the information. So, ultimately, we have to go through the process to see where you really end up with the project. It was just, we felt like as the agency, that's the recommended alternative that we would put forward.
Very cool. So Kipp and I actually covered this a podcast or two ago, where we got the diagrams of, here's the two bridges, here's where they're going to put the first one, then they take this down, then they put this one, then they take that down, right? And we went through, because I had trouble comprehending it at first until the text version, right? When the first thing that came out only explained it in text form. Then once I saw the pictures, I'm like, okay, now third grade Mike can figure out what's going on. And so because I was having trouble seeing it from a text perspective, I thought it was good for us to cover. So how many alternative plans are there for that one location?
I think it's up to 8 variations. And that just, it has to do with, if you think about location for each of the different combination of lanes that you could have, lanes on land versus lanes on bridge, you start to, and then you do that twice, because it's like, is it north of or is it south of, right? So then you start, it just kind of doubles everything up. So I think it's either 8 or 10 total when you think about it. So there's always the no build, and then you have, whether it's currently, right, 6, it's a 6, lanes on land and 5 on bridge. And so then is the new one 6 and 6 and 6, or 6 and 8 and 6, or 8 lanes on land and 10 on the, so you just, you start going through those, and it's both locations, then you kind of end up with a lot of options to think about. So
Very cool.
The process of having the board sort of recognize that the 686 alternative is the one that MDTA is really considering. It gives people a chance to kind of hone in on that if they want to, and support it or raise issues with it, but it still keeps all the other ones on the table as well. If they really support another variety, another alternative, they can certainly weigh in on it and have their thoughts heard. So, but in terms of some of that, it could be built this way. It's all sort of just at the planning level now. Once we would get to a record of decision by the end of the year, then you would need to sort of go into that design that we're doing on the Key Bridge. The same kind of efforts where you really start to look at, okay, we know we want a bridge that goes to the south or to the north, and then we have another one in the middle. Well, okay, how do we build that? How do we demo? which one makes sense, which one do we need first or second, and so you start to really get into that. You get into the details of how you transition, on your number of lanes on land, and really what that looks like. Right now, you're at that 30-foot, level, or 30,000-foot level. And you're just kind of saying what you need, and then how you get there really, bakes out, in the years following. So,
Gotcha. Speaking of years following, I was also joking around on because, I've lived here all my life. Me and my dad always took the boat and went down to Y River or Crab Alley, and we're crabbing. So I couldn't even begin to guesstimate how many times I've been over that bridge, right? And as my dad's driving in the fast lane, he's leaning out the window. Go to heck! Look, do you see the size of that rockfish? I'm like, would you keep your eyes on the road, please? You're freaking me out. So it means a lot to me. I've grown up with this bridge, and, when I hear about people who are scared of it, I'm like, really? Even though my wife is one of those folks, and she's determined that she's just going to keep driving over it because she knows when she stops, she's not going to do it anymore. But, so I was joking around about, I was just like thinking about it in my head, and I don't know what year I came up with, but I was like, I'm going to have my stepson come by, grab the wheelchair, wheel me out to the car, pick my butt up, put me in the passenger seat, drive me over that bridge. I want to see it. I want to see both of them. So, how much longer is that going to take?
That's a good question. So,
okay.
we had to put out some information right on cost and schedule. It's just what you need to do as part of your study, and so we kind of laid out a timeline that was, if everything were able to fall into place, you got the record of decision this year, you went through the procurement to get a design team, you get into all the design and permitting. We projected we could start construction in 2032.
Mm-hmm.
And so, the next follow-on question is, well, how long is construction? And that's something that it's hard to say when, we don't know what we're building, right? And so we, kind of had that with the Key Bridge, and so really hesitant to say what that looks like for a bridge that I don't really, know what we're doing there yet.
Gotcha.
We're still
I'm
determining
sticking to my wheelchair story then.
Yeah. Sticking to
I
the
want to see
wheelchair.
it.
But
Take me over.
Yeah.
I don't care. Hey, so back to the Key Bridge and the protection islands, the biggest protection islands, a football field size and 20 feet of concrete. I mean, will that be like a constant pour for God knows how long? How many trucks is that? How long would that take? Any idea?
So I'm not exactly sure on the quantity of concrete in those. I want to say it exceeded the 45,000 cubic yards, but on, say, the footings for the pylons, I know that those were at 15,000 cubic yards. So it's 1,300 truckloads of concrete if you did it by truck for the footings. And the footings are 2 NBA basketball courts, in terms of area, and like you said, they're 20 foot deep. So there's substantially more concrete in the vessel protection in the fender, but it wouldn't necessarily be a single pour. That's just too much. So you're gonna break it up. You're gonna do it in certain discrete pours. The foundations, for instance, we're doing those in like 3 lifts. But on the vessel protection, part of the reason we're still working through the design details. So part of it is, that we're getting into this where we've reached 70% at the end of November. That 70% allows us to, go to estimating. But at the same time, you're still, refining your design. So we're still working towards that 100% design level, which essentially, we know the size of, the vessel protection, but exactly how you construct it and how you detail everything is still being determined. So we're still working through some of these questions in terms of exactly how we're building those. So more to come on that, but it is a mass concrete operation, just like the footings for the pylons. Like the pylons themselves are all kind of this mass concrete operation that we need to undertake, and just more details about how that to come. But we're still detailing it out. We're still working through all the means and methods with our contractor to really finalize what that ends up looking at like.
Okay, so I think you just answered one of my questions, so that's cool.
Okay.
Because I was curious, what is left to design? What are the specifics of what's left?
Yeah.
And so that was probably a good enough answer.
In terms of this design, the way the design progresses, you have the full scope of your project, this, more than 2 mile bridge, and that you're building a bridge, and then you start as you develop your design, you just really start to really develop those details. So while it'll have this many piers and it's going to be this wide, and then you start to, okay, well, what size do those piers? What shape do those piers? What are we doing with the pier cap? How are we building, the bridge superstructure? What does that all look like? And so as you start to develop that design, so from 70 to 100, you're like, well, okay, what happens? Well, you just really start to hone in on the details for, like, say the rebar and some of the different sizing on some of the materials that you really need to get to the the final number. And so that's what will be happening over the next couple of months as we go from 70 to 100%. Is just getting all those exact details right for the contractor to go ahead and build the project. So we have enough at 70% to estimate the project. It's just refining all the details in terms of the ability for the contractor to construct off of it.
Do will there be any kind of decorative lighting, for lack of a better term? I know you all had mentioned this a couple of times, but I'm kind of looking for like a yes or a no, because we see that on so many of these cable stay bridges.
Yes, there will be aesthetic lighting. We have that in the current design, just for estimating purposes, because this is an area where we want to go to the public, get some public feedback on it, exactly what it may look like. So we have some assumptions that we've made in order for to advance design. So we have it included in the current design, and then it's just getting those specifics nailed down so that we can get the exact number of fixtures and the lighting cable requirements and that kind of information just nailed down for the final 100% design. But it is included, and it's something that we'll be going out and soliciting some feedback on.
I think it would be cool to celebrate a Super Bowl or World Series win with the appropriate sports team colors plastering the bridge. So that's if I could put a plug in, that's there's my plug right there. So.
Kip, I love you, man.
And that's the kind of feedback during the public process. We'd probably be looking to solicit ideas like that.
That'd be cool. And I just came up with this, and I wonder if the Maryland Pilots Association has any kind of input, like, okay, like if you're going to have lights that are moving, don't sequence them when bridge ships are coming through, or stay away from these colors, or stay away from lighting this at this time. I have no idea. I'm just guessing, but I wonder if they would have any input.
Yeah, so we work closely, through the Harbor Safety Committee with the Pilots Association. Obviously, U.S. Coast Guard is a partner in the project, so you have to take lighting through the U.S. Coast Guard. So we have our standard Coast Guard required navigational lighting, hazard marking lighting. So we have that, and then as you kind of it's important to make sure that those don't conflict, your aesthetic lighting with your safety lighting, right? So we also have FAA required lighting that would be on the bridge as well. So we have that coordination that we would have to undergo once we know exactly what we're doing there in terms of lighting, aesthetic lighting.
Maybe one or two more questions. And this one was something that I thought about early, probably 10, 20 minutes ago. So can you, I don't know, maybe quickly talk about, when we look at the bridge in Tampa, they chose to use like a plethora of dolphins. And now we're not doing that, and we're doing these protection islands. Can you talk about, are those dictated by that code that we were talking about earlier, or was that kind of an option? Can you elaborate on that at all?
Yeah. So the type of protection isn't necessarily dictated by the specification from AASHTO. What ends up dictating, what you use is a lot of times your project conditions. So your soil conditions at the project, your vessel type, your design vessel. If you're, say down at the Nice Bridge, Nice Middleton Bridge in Southern Maryland,
Right.
you're getting some barge traffic, very little barge traffic, as
Right.
opposed to what we see at the bay and at the Key Bridge.
Sure.
So those various factors feed into what you can design and meet that specification, using. So, there's a couple of common types of protection. The rock island, which is exactly what its name states, is just you make an island full of rock around your piers, and that serves to force the ship to ground and basically fight its own weight as it tries to push up the rock island and come to a stop before it hits your pier. Then there's the dolphins, and the dolphins are sort of these self-contained sort of cellular units that have to go into the soil, and so you have to take into account your soil types and what factors you have there, and then you start to have to size those and get larger radii based again on how much energy from your design vessel that you're trying to have to deal with. So you start to look at all those and your your site conditions, and then that sort of flushes out what you need to build in order to meet that specification. And so all those things are a variety of things that we went through during design to try to figure out how we're going to meet that specification for this particular project.
Interesting. Yeah, I can. I'm glad you explained it in that way, because I can imagine. If you have a bunch of smaller dolphins, the structure that are underneath them, so that they just don't fall over when a ship hits it, almost seems to be a lot more significant for something sitting out by itself than if you built a box around something that was already pretty significant. And then Tampa, you imagine that the ship that they used to get their calculations in the 80s was much smaller than the ones that you're going to use or are using or did use for Key Bridge.
Yeah, you can imagine, at the time they ran through that project, they went through and looked at the vessels that they thought were going to be coming to the port at the time, and so they ran through those calculations, and so they ended up with that, like you said, a very large array of dolphin system there. So at our site and for our project, it's going to be different, and this project could be different than the Bay Bridge. So you may see something different at the Bay Bridge because it's the geophysical conditions are just not going to be the same necessarily. So you may end up with something different, eventually on the Bay Bridge. And so, yeah, we looked at a couple of varieties of protection systems, and working through and meeting that specification led us to to where we are with the what we're calling the rigid fender system.
Very cool. Thanks so much. Kip, do you have anything? I do
No,
kind
I
of
think
have one more if we have time. If we don't, that's fine. You can go ahead and wrap it up then if you want.
Yeah, so no, I think I'm good. That kind of covers, I think, the the questions that we had collected, and that we had heard some questions coming in from the viewership, and had kind of written some of them down. So that we kind of kept that running list. So I think that covers everything for this point. That really was a comprehensive overview of everything that's coming up to this point. So
thanks so much to everyone at MDTA, and of course you,
Absolutely.
Jim, for coming on. And because I mean, it's great that you show what's going on socials, but to be able to sit down and ask some detailed questions,
Absolutely.
I think really helps folks to see what's going on, and so we can't thank you enough for coming on.
Yeah, absolutely.
Yeah.
Thank you for that time and the transparency and explaining. There's a lot of things that you explained today that explains the why, that answers a lot of those questions that are out there. So I hope that folks get a chance to listen and understand what all's going on. So thank you for that time and effort.
Yeah, that's great. We appreciate the opportunity. We love to talk about the project. We definitely make it a point to get out and not only do stuff on social, but try to engage in the community, pop-up events, doing community presentations. We're always on board for trying to talk about the project and help people understand it and answer questions. That was a main focus from the outset, and continued focus as we move forward. So the next couple of months, we're going to be out there continuing to work on the river, driving production pile, putting trestle pile in. We're going to continue with that design, advancing it to 100%, and contractor and MDTA are both estimating the project right now. So over the next few months, we'll continue that. We'll wrap the estimating up, and we'll get together and start trying to negotiate to see if we can't come to an agreement for that phase 2 for the ultimate construction, which would possibly happen in late spring, early summer, and let us keep on going and building this bridge.
Excellent. We'd like to have you back on. Appreciate you are the first repeat offender here, I believe. Is that correct? It's for guest interviews. So we appreciate that. We'd love to have you back on. Maybe let's go another 6 months or so and see how much further the project has progressed. We'd love to hear some updates.
I think that'd be great timing, I think. So look forward to it.
All right, everybody. Thanks so much, Jim Harkness, on the Two Guys Talking Ship podcast.
Thanks, Jim.
Thank you.
That was a lot of information.
Wasn't it? Man, that was a lot of great detailed information. Like I said to Jim, it's great to see all the stuff that they put out on social, and it's good to kind of watch stuff on the camera, and it's good to hear things, but when you can sit down and really talk to somebody,
not just somebody, he's
right.
He's the guy running the joint,
Yeah. Okay, when you can sit down and talk to the guy, let me correct myself.
I feel pretty lucky to have that opportunity, and for MDTA to really be that, again, transparent and explain, here are all the things that are going on. So, I mean, it's right there, and especially like what you were talking with him with the, the actual pictures, and then kind of explaining it, and that they were putting that out. So that was
Right.
I appreciate that. I found it interesting what he was saying about the Bay Bridge in that process and the connectivity. I know that wasn't something that we had originally planned on discussing, but I kind of was wondering, hey, look, you're building a bridge and you're really addressing the currency and the future of ship traffic, but we also have this bridge down a little bit further south from us, and it's in the news also. Are we, are you looking at those things? And I had a feeling that they, of course they are, but for him to come out and explain the connectivity between the two bridges, I thought was important. So,
yeah, great stuff. That was a nice surprise.
Yeah.
In no way did I think that we were going to talk about the Bay Bridge.
No.
So that was a nice addition.
So that's I appreciate that. And I hope that they come back on and continue to provide that information with us. And viewership is appreciative of their time on that also. So.
Really will be fascinating. I mean, it's all fascinating, right? It'll be, feel silly, but it's going to be fascinating to me for the next 4 years.
Oh, absolutely.
But to have him on again to talk about, maybe, okay, we've got it 100% designed. We each came up with an estimate. How close were they? Are we going to keep going with Kiewit?
Yep.
Are we going to do the off-ramp thing? So, wow, lots to anticipate. Whatever 5-6 months from now when we have them back on.
Absolutely. All righty. Well, that's that was a full episode in itself right there. Be back with episode 66 in our regular format and provide you with all the updates and metrics and everything that we normally do on that. This was just a special opportunity for us this time.
Yeah, I think we've already got some new key bridge stuff. We got all kinds of pictures about the barge carrying the rocket nose cone and more information on that. So we've already got stuff in the hopper for the next episode.
So with the winter storm coming into the area in the next couple of days, we might have some opportunity to put it all together. So
that's true. That is true. I really didn't think of that, but that's a good point. You might have a lot of time to put it together. Hey, so as we get done here, we're Two Guys Talking Ship podcast, sponsored by Baltimore and Chesapeake Bay Shipwatchers. And the Shipwatchers have quite a presence on social media. So we're on Twix. Shout out Amy Lawrence. That's Twitter and X. Instagram, Reddit, Threads, obviously YouTube for the podcast here. A website full of maps, information, swag, ship schedules, link to the podcast, link to the cameras. Oh, while we're on that, the cameras have been down for since yesterday at maybe 9 o'clock in the morning.
Okay.
Supposedly the power or the cable has been disconnected or cut at the host location of the camera. So, they're supposed to come by this afternoon and fix that. So hopefully,
okay,
yeah,
good to know. And if you want to listen to the audio version of this, we're on Spotify and Apple Podcasts.
Yeah, since we had no pretty graphics, and who wants to see these three heads anyway?
I agree. I did. So in the last episode when we counted it off, and you recorded your happy ship watching way off out of sync, the AI did sync it back up.
Really?
Yeah.
That's interesting. Now, how long have we had that?
I don't know. Oh, since we started doing this.
Oh, really? Oh, I thought that was a new feature.
Oh, the AI.
AI syncing.
Oh, I don't know. I think that's been doing it the whole time.
Oh, interesting.
So we can continue to not have to worry
Just
about getting
be
the timing
horrible, and it'll fix it for us.
Thanks for helping us out, software.
Yeah.
All right, 3, 2, 1. Happy ship
watching. All right, we don't need any stupid AI. We
That's right.
nailed
We
that.
get to do it.
All right, everyone. Really hope you enjoyed this special edition of the Two Guys Talking Ship podcast, and we'll see you on the next one.